My name is Mukesh from CC Year 2, and this is my presentation, The Intelligent Connected World, in which we're gonna see how machine learning, robotics, and IoT are shaping the future. So, in this presentation, we're gonna explore the intersections of the three powerhouse technologies: machine learning, robotics, and Internet of Things (IoT). These things aren't just like individual tools anymore. They are the core pillars shaping our modern society. As these fields evolve, they're moving away from being isolated systems. Instead, they are merging into a single integrated ecosystem where every part works together to or to make our world significantly smarter and more efficient. To put it simply, think of it think of machine learning as the brain that processes patterns. Robotics serves the body, performs the physical tasks with pinpoint accuracy. Finally, the Internet of Things act as like their nervous system, allowing all these parts to communicate and share vital information in real time. When we combine these three, we create truly intelligent systems. These systems don't just follow instructions, they interact, adapt, and make high level decisions with minimal human intervention. Throughout this presentation, we'll also see how this integration is boosting productivity across industries and pushing us towards a future that is more connected and intelligent than ever before. So, the machine learning, the brain. Let's dive deeper into machine learning, the engine behind today's smartest digital environments. At its core, ML allows computers to ingest massive amounts of data, using it to learn, predict, and make informed choices. By identifying deep relations with the data, technology can now recognize trends and solve problems that are like once so difficult and complex for standard programming. throughout throughout a continuous cycle of algorithms and model trainings, the system is always refining its own logic. Adaption. The beauty of this technology is that it gets better with age. As more data flows in, the system becomes increasingly accurate and efficient. This journey didn't start yesterday. It began with pioneers like Alan Turing and the landmark Dartmouth workshop, which officially launched AI as a field of study. The shift happened when we moved from giving machines explicit instructions to creating algorithms that could learn on their own. More recently, deep learning and neural networks have revolutionized uh, how machines understand human speech and images. Today, ML machine language is like is integrated into every sector, solving complex daily problems across various industries. So let's talk about the key innovations and applications of machine learning. Google Mind. Companies like Google Mind are pushing these frontiers even further, from mastering games to making major scientific discoveries. OpenAI. OpenAI has pioneered the large language models that are recently redefining how we interact with technology. NVIDIA. And behind the scenes, NVIDIA provides the essential hardware and software that accelerate this entire AI revolution. And then, as well as medical diagnosis in the real world, This looks like AI helping doctors identify diseases faster and with much higher accuracy. And then we have fraud detection. In finance, it means securing your transaction by identifying suspicious patterns the second they happen. So this is the flowchart of machine learning. This flowchart basically shows how the process of building a machine learning model. It starts with collecting data, which is then cleaned and prepared during processing. After that, the data is used and like used for training the algorithm and stuff. And then finally, the model goes through evaluation to test its accuracy and to be used in like real world applications. And this is the UML diagram as well. So, what are the challenges? Every good thing has positives, but every good thing also has negatives as well. So, the risks. These, however, we must also like address the risks as well, such as algorithm, algorithmic bias to ensure these systems are fair and non-discriminatory. Privacy concerns as well, of course. We also have to like be vigilant about privacy, protecting the sensitive data used to train these powerful models. Of course, displacement. These can also displace so many people, losing people's jobs, and so many people can lose their jobs by machine learning. And then we have responsibility and the guidelines. So finally we establish clear ethical guidelines for automation decision making and responsibility. So the next topic, robotics. Robotics. So moving from the brain to the body, robotics is physical application of that intelligence. Robots are designed to assist us when we might lack the strength, precision, or the ability to work 24/7 without a break. From manufacturing to healthcare, robots provide the reliability needed for repetitive and high stake tasks. As technology matures, robots are becoming capable enough to work right alongside humans in diverse industries. We've come a long way from the first industrial robots that handle basic factory tasks from 1960s. Today, we have surgical robots that assist in delicate medical procedure, leading to better outcome for all the patients. So let's talk about some capabilities in robotics. We have agricultural robotics, uh, we have surgical automations, we have autonomous vehicles, all these things. So surgical robotics that can assist people with procedures and make a better outcome for patients. Agricultural robots in the fields are now like planting and harvesting crops with incredible precision. And even on the roads, self-driving cars and drones are completely transforming how we move the goods and people. Let's look at this Boston. Look at this Boston dynamic, who have refined what we thought was possible for robot agility and automation. And then we have Tesla Robotics. Tesla is working hard to bring humanoid robots into the fold, aiming to automate even more of our physical world. And then we have ABB. Global leaders like ABB continue to provide the industrial solutions that keep modern factories running. And then we have robots that are used for dangerous uh, labor as well, which are like greatest benefits is sending robots into hazardous environments to keep humans far from like harm. And then we have robots which have perfect accuracy, precision, which can make a accurately needing tasks to be accurate. So let's talk about the negatives of this as well. So first thing is military misuse potential. On this side, we do have to consider that ethical implications of autonomous weapons and military misusage, in which militaries and countries can use these robotics to like to misuse them potentially. High cost as well. We also can't forget the high cost of implementations, which can be a barrier for smaller businesses. And then we have human skill loss. There is also a risk of over reliance, where we might lose certain human skills and critical thinking. And then we have control and shared spaces. Ensuring these robots operate safely and reliably in shared human spaces remains a top priority as well. Let's move on to Internet of Things, the nervous system. Technically, technically, the nervous system IoT automations automates our homes from lightning from lighting to security and for maximum convenience. Everywhere in the world right now we have sensors and all the mostly everything is automated right now. So technically, IoT is a massive network of interconnected devices that are constantly talking to each other over the internet. It turns everyday objects like and uh, uh, appliances and sensors into part of continuous digital conservation. This data creates smarter, more responsive environments in our cities, homes, and workplaces. IoT works by collecting data via sensors, processing it in the cloud, and using real-time analytics to trigger a response. Monitoring and automation. This allows us to monitor conditions and automate tasks in a way that very previously was impossible. So we have smart cities, you can see smart cities, and then we have industrial automation, and then we have healthcare monitoring. So in factories, it connects like in industrial automation, IoT connects the entire supply chain, allowing for predictive maintenance before a machine even breaks. And then for healthcare monitoring, we have uh, variables which allow for like constant patient tracking and instant emergency alerts. And then this is the robotics flowchart. This is a basic flowchart as well, which shows a sensor input and that which collects data and gives feedback for from the surgical environment. So this is a flowchart for a surgical robot, and then these are the, of course, the negatives of IoT as well. So, however, like more connections mean more targets for cyber attacks, making security a primary concern. And then we have surveillance and privacy again. Since it's everything is automated, we must also manage the line between helpful data collection and invasive surveillance. And then we have data overload management, managing the sheer volume of data produced is massive technical challenge by itself, of course. And then we have interoperability, which is like we need to ensure that different devices from different brands can actually speak to each other in the same language. So let's talk about how everything is connected. IoT as a data source which connects data which feeds ML. So yeah, the true magic happens when these technologies meet. IoT acts as the primary source of real world data, and then this This massive stream of information is the perfect food for machine learning systems. Training and predictions. Machine learning takes that IoT data to train its models and make increasingly accurate predictions. And then this energy allows systems to optimize their performances based on actual changing conditions in real time. This intelligence is what transforms a robot from a simple pre-programmed machine into a adaptable agent. By analyzing sensor data, ML allows robots to respond to complex, unpredictable situations. Robots are no longer limited by their code. They can now learn from experience and improve over time. This allows them to work alongside humans in fields like logistics and healthcare with incredible flexibility. Ultimately, robots use the insights from IoT and machine learning to take a meaningful physical action in our world. This means decisions can be made and tasks performed without a human having to step in every time. This synergy is already enhancing smart factories, environmental monitoring, and emergency responses. So, transforming uh, daily life. These technologies are reshaping how we communicate, work, and interact with the environment. To ensure that benefits reach everyone, we must address the digital divide and ensure equitable access. So, to ensure uh, to ultimately robots use the insights from IoT machine learning to take meaningful actions in our world. These technologies are reshaping how we communicate, work, and interact with our own environment. To in, to ensure we have a responsibility uh, to ensure that these algorithms operate fairly and that is clear accountability for the decisions. On the brighter sides, this On the brighter side, this connected world offers huge potential for sustainability, from reducing waste to managing energy. However, we need strong regulations to manage data responsibly and uphold cybersecurity standards. The future horizons. As we move forward, the landscape of employment will change, requiring us to constantly upskill. We will see new forms of collaborations between humans and machines. Ultimately, this automation is designed to improve our quality of life through safety and efficiency. In summary, we aren't just looking at isolated gadgets, we are looking at a fully integrated ecosystem. The future is interconnected. By embracing these opportunities and navigating the risks, we can build a future that is in, inclusive, efficient, and connected for everyone. Thank you.